Welcome to Building Robodoc, an idiot's guide to artificial intelligence in healthcare. Hi, and welcome to the very first episode of this podcast series. Over this and the following episodes, we'll be exploring some of the big ideas behind modern artificial intelligence, as well as its impact, both present and future, on the world of healthcare. We're going to do this from the ground upwards, assuming no prior knowledge of the field of computer science, or indeed the field of healthcare. Let me start by introducing myself and explaining why I'm doing this. My name's Rob, and I usually work as a cardiology doctor here in the UK's National Health Service, though at the moment I'm taking a sabbatical to do some research. Until about 2 years ago, like 99% of my colleagues, I knew nothing about AI, except that I was beginning to encounter those two letters more and more in newspapers and on TV. I assumed that it was a bit like the way that technophiles get themselves overexcited about a new generation of iPhones or the latest PlayStation model hitting the market. From most people's point of view, it's ultimately much ado about nothing. It was when a Google computer system called AlphaGo beat this guy Lee Sedol, who's a world champion at the ancient Chinese game of Go, that I started properly paying attention. This definitely isn't because I'm a massive Go fan. In fact, I'd never even heard of Go until then, but rather because some really smart people who I had heard of were heralding this as potentially the most significant technological event of our time. And I didn't like the fact that I had no idea why they were saying this. Given that I was born at a time when Atari was still the cutting edge of home computing technology, and that the term World Wide Web wasn't even coined until I was 5 years old, that's quite a claim. I decided then that it was time I found out more. And luckily for me, unlike 99% of my colleagues, I had enough of a background in computer science to allow me to take a slightly deeper dive. What I discovered was that for once, this technology really does seem to live up to the hype. Artificially intelligent computer systems, in the world of healthcare specifically, are already able to detect breast cancers earlier than human radiologists, diagnosed skin cancers as well as expert dermatologists, and read ECGs at the level of experienced cardiologists. And this is only the very beginning. AI could revolutionise healthcare on the scale of the invention of the X-ray machine or the discovery of antibiotics. And yet most people, healthcare professionals or otherwise, are so put off by the technical language and perhaps the fact that AI falls into the domain of computer science, which most people don't like, that they have zero interest in learning even the very basics of how it actually works. I think this isn't okay anymore. A few weeks ago, the Institute for Public Policy Research, which is a big UK think tank, released a paper suggesting that AI-based technology could save the NHS up to £12.5 billion a year, which is maybe, $20 billion. Much of it by relieving staff from more mundane duties and freeing them up for uniquely human tasks. For anyone who doesn't know, the NHS, which just had its 70th anniversary recently, it's in its death throes. And whatever led us to this point, whether it be the ageing population, more expensive treatments, chronic underfunding, a lot of its current problems boil down to a lack of money and a lack of staff. Now, I'm one of many people who would say that a free at point of access healthcare system run cooperatively by a society of more than 70 million people is perhaps one of mankind's greatest achievements. If AI technology could single-handedly save this or at least make a big dent in its crippling problems, it's inexcusable that we, either as frontline healthcare professionals or as patients, don't start to get to grips with it. So without further ado, let me try to share with you some of the intuitions I've gained about artificial intelligence over the last couple of years. The first issue we need to address is, what is artificial intelligence? The Encyclopaedia Britannica entry on AI starts with the line, "Artificial intelligence is the ability of a digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings." This seems as reasonable a definition as any, but the trouble is that the goalposts of what is and isn't commonly associated with intelligent beings are constantly shifting. In the 1960s, chess-playing computer programs began to consistently beat amateur human players. In the 1980s, computers developed the ability to read human handwriting. Throughout the 90s, I spent countless hours racing against computer-controlled go-karts, and these would drive more or less skillfully to match my own performance. This is Mario Kart I'm talking about for any other aficionados out there. All of the things I've just mentioned would have fallen under this definition of tasks commonly associated with intelligent beings, but clearly none of them are the reason that billions of dollars are being poured into AI research by the likes of Google, Microsoft, Facebook, Tesla, of course, and so on. So what is the reason? Well, in 2018, when you hear about artificial intelligence on the news, it's usually referring to the subset of computer programs that are based on machine learning principles, which I'll explain in a moment. I am actually going to use the terms machine learning and artificial intelligence somewhat interchangeably during this series, but I think it's probably important to point out at least once that a lot of computer scientists might object to this. Many conventional, or what we would call rule-based computer systems are deemed to fall under the umbrella of artificial intelligence too, and appropriately so. But you do have to draw an arbitrary line in the sand somewhere, and rightly or wrongly, I'm doing it here. Anyway, to get a sense of what machine learning is about, you first need to understand that conventionally, in order to get a computer to do anything, you need to give it an exhaustive set of instructions describing exactly each step of the task you want it to perform. And by the way, these instructions are of course written in computer code, and we call them scripts, just like the script that tells an actor what to do in a play or a film. This is because computers are inherently unintelligent. They have no more intrinsic knowledge or sense of purpose than a hammer or a chisel. The incredible software that we take for granted in the 21st century, so think Microsoft Windows, iTunes, Xbox games, etc., they represent the culmination of more than 50 years of programming, built layer upon layer like a pyramid. These days, you can write a simple computer program in a few lines of code, but it's easy to forget that in order for a computer to execute that code, someone, at some point in time, has painstakingly described how to perform every single step of the incredibly complex electrical process that's taking place within its microcircuitry. And that starts with how much electrical current to run through each individual wire on a rudimentary circuit board in order to perform basic mathematical calculations. And in the mid-20th century, pioneers at Manchester University were making the first programmable computers by writing code at this kind of level. All of this historical knowledge is of course built into most modern PCs and consumer devices at the point of manufacture, so we don't often have to think about it, but that is essentially how things work. Machine learning is different. Instead of painstakingly explaining to a computer exactly how to perform a given task, you essentially show it the task you want it to perform, write a short bit of code telling it how to learn, and then let it figure out the rest for itself. This might sound a bit vague and technical at this point, but in the next podcast we'll talk a little bit more about how and why it actually works, and the slightly magical results you can achieve with this kind of computing strategy.